Okay, so we'll now go over the electrolysis of dilute sodium chloride. In the previous video, we went over the products that are formed when there's a concentrated sodium chloride solution being electrolyzed. So let's just go over the electrolysis of dilute sodium chloride now. So in a dilute solution, there are fewer chloride ions, and obviously there are fewer sodium ions, right? So dilute means that there is less solute in the solution. So in a dilute solution, there are fewer chloride ions and a different product is made. So water ionizes a little to give both hydrogen and hydroxide ions. In dilute solution, it is the hydroxide ions that are discharged at the anode. So remember that uh, in the concentrated sodium chloride solution at the anode, because chloride ions were in so much more concentration as compared to hydroxide ions, that's why they were getting discharged. But in this case, what's happening is that hydroxide ions will get discharged because now they are in relatively higher concentration. Okay, so बाकी जो cathode के ऊपर जो product होता है, it's literally the same. Okay, hydroxide ions turn into water and oxygen gas at the anode, and oxygen gas bubbles off. Okay, so this is the difference between the electrolysis of dilute and and concentrated sodium chloride solution. The product at the cathode remains same. Yeah, so whether you have a dilute solution or you have a concentrated solution, it will always be hydrogen gas at the cathode. But at the anode, you'll get a different product. So when you have a concentrated solution, so you'll get chlorine gas, and when you have like a dilute solution, so you'll get oxygen gas bubbles. So yeah, so that's the difference between the electrolysis of dilute and concentrated sodium chloride solution. Okay, so now let's just move on to another high yield example of an aqueous, not an aqueous ion, but it's like uh, diatomic ionic compound. Okay, this is also very high yield for your Cambridge exams. So this is kind of easy. The reason is, okay, there are no competing ions in this case. Okay, it's a molten form of lead to bromide. That means there is only lead, and then there is only bromide ions. So as you would expect, and it should be pretty trivial at this point. So as you would expect, at the anode, the bromide ions will get discharged and bromine gas will be given off. And you would know that because when electricity is flowing, brown fumes of bromine gas are seen at the anode, right? So bromide ions are getting discharged and bromine gas is produced at the anode. At the cathode, what is happening is that when the electricity is flowing, a silvery deposit of lead metal forms on the cathode. So obviously the lead ions will get discharged at the cathode, and that will, just result in deposition of that lead on the electrode. Okay, you'll see the deposition of a silvery deposit of lead metal on the cathode. Okay. So now we have our final example, that is the electrolysis of aqueous sulfuric acid. So as sulfuric acid is aqueous, it is composed not only of hydrogen and sulfate ions. So let's just break it down. Okay. We have sulfuric acid. Sulfuric acid is written, it has a chemical formula of H2SO4, right? So if you break this down into positive ions and negative ions, so Maham, आप बल्कि रफी जल्दी से बताओ कि what are the positive ions and what are the negative ions in the solution?
Positive is hydrogen and negative is sulfur
Good.
and
And
also oxygen,
oxygen,
OH.
OH, ठीक है, very good. So पॉजिटिव वाले जो हैं वो आप सिर्फ हाइड्रोजन ही हैं, सही है। तो अब तो सबको पता है कि ऑब्वियसली कैथोड के ऊपर क्या प्रोडक्ट होगा, हाइड्रोजन गैस, ठीक है, क्योंकि है ही वही आयन। इधर मसला बनता है, ठीक है। द रियल प्रॉब्लम इज व्हेन यू आर डीलिंग विद two ions which are competing for the same electrode. सही है। So the problem arises when you have to decide which of these two will be getting discharged. So let's just, at the cathode, obviously you're seeing here that hydrogen gas is being formed. But at the anode, what happens is that at the anode, hydroxide is easier to get discharged compared to sulfate ions. So oxygen gas is given off at the anode. Okay. And this is the same concept we learned. Uh, uh, see, so that's the same concept because hydroxide ions are way down in the reactivity series as compared to sulfate ions. Okay. They are like at the top. Okay, so they will never get discharged whenever you have any of these competing with it. Okay. So hydroxide ions are way less reactive than sulfate ions, and that's why they're getting discharged preferentially at the anode, right? So with electrolysis of aqueous solution of dilute acids of alkalis, the volume of hydrogen given off at the anode is roughly twice that of oxygen gas at the is roughly twice that of the oxygen gas at the anode. So what is the reason behind particular uh, this particular finding in electrolysis? Can you just read this and explain? Just read this first and then explain. Okay, why is it so?
With the electrolysis of aqueous solutions of dilute acids of alkalis, the volume of hydrogen given off at the cathode is roughly twice that of the oxygen gas at the anode.
Yeah. So what do you think is the reason behind this? Any ideas?
There's more hydrogen.
Yeah, exactly. Okay. Ab you can see here कि जो aqueous solution आप ले रहे हैं, for example, if you take an aqueous solution of sulfuric acid again, there are hydrogen ions coming from sulfuric acid. ठीक है? There are hydrogen ions coming from sulfuric acid, and there are also hydrogen ions coming from the water. ठीक है? दोनों से आ रहे हैं hydrogen ions, right? One from the water, H2O, sorry, and then sulfuric acid as well. So that's why the at the cathode, the amount of hydrogen gas that is found is roughly twice that of the oxygen gas. The oxygen gas की तो एक ही source है ना, hydroxide ions from the water, but hydrogen की source जो है, it is like the acid as well and the water as well. So accordingly, the elements of water are lost. ठीक है, electrolysis continues and the concentration of the acid or alkali increases. सही है. And yeah, so hydrogen and oxygen are given off in a ratio of 1:1. Okay, so yeah, so this is just a summary of the electrolysis of solutions using carbon electrodes, which are inert electrodes. So number one, if the metal is high in the reactivity series, hydrogen is produced instead of the metal. Okay, you guys saw okay, hydrogen is way down in the reactivity series, like it's at the very bottom. So yeah, so unless the metal is like platinum or gold, which are the most least reactive metals, so hydrogen will be formed. ठीक है, तो जब भी कोई इलेक्ट्रोलिसिस हो रहा हो ना, सही है, you shouldn't doubt. ठीक है, आंखें बंद करके ना कैथोड पे ना हाइड्रोजन बनती है. सही है, अगर फॉर एग्जांपल उससे कम रिएक्टिव मेटल ना हो. ठीक है, फॉर एग्जांपल हाइड्रोजन से कम रिएक्टिव मेटल्स जो हैं, उसमें अगर हम देखें रिएक्टिविटी सीरीज में, सो वी कैन सी दैट hydrogen is here, but copper is less reactive than hydrogen. Silver, gold और platinum जो है ना, अगर ये होंगे ना solution में, so they will be getting discharged. लेकिन बाकी the majority of the metals, ठीक है, if they are competing with hydrogen, ठीक है, they will never win. So yeah, hydrogen will always get discharged because it is way less reactive. So yeah, it will preferentially get discharged. सही हो गया. अच्छा, now uh, if the metal is below hydrogen in the reactivity series, the metal is produced obviously. So if you have reasonably concentrated solution of halides, so chlorides, bromides, iodides, the halogen is produced with other common negative ions. Oxygen is produced. Okay? So we saw that in our example of the concentrated solution of sodium chloride and solution of sodium chloride. And we learned that uh, in the dilute solution, the products are different at the anode. So you get oxygen gas at the anode, whereas in a concentrated solution, you get chloride gas instead. Sorry, not chloride, chlorine gas instead. Yeah. So that's all for our lecture on preferential discharge and the electrolysis of specific aqueous solutions.